We have spent a crazy, welcome back, Algebraists, by the way. We have spent a bunch of time this year and the last several chapters, especially factoring. Would you guys agree? Now, primarily when we factor, like the bulk of the factoring that we've done up until very recently has all been focused around which power or which degree function. Like our whole roadmap that we went through was all focused around trinomials where the biggest exponent was what? A 2. Now, I'm going to write something really ugly, and we don't like this is just to address number 15 from the homework. This is not a note thing, but I want to show you guys that we've done things like this, but it can be kind of tricky. If I write this expression, ax to the 2n plus bx to the n plus c, does this look kind of familiar? Like, it kind of looks like a quadratic, doesn't it? Almost. If n is 1, would this look like just a regular quadratic? Ax squared plus bx plus c. Now, in this form, this is what we've really been dealing with. If this happens, we know that we can do this and we can continue on. Okay, so I'm going to write two different problems, and I just want to see if we can do either or both. And I lied, this is number 16 on your homework. And we're building up to it. If I gave you this, 9x squared minus 40x plus 16, could you factor and solve this one? Okay, what would we do? What's always the first thing we check? Okay, GCF. Is there one? No, bummer. So then we have to go bigger, right? 9 times 16, I think, is 144. It feels like it's 144. Okay, now we need factors that multiply to be 144 but add up to this. And I have a sneaking suspicion it's probably 36 and 4. Negative 36 and negative 4 is what we'll need. Okay, and the rest of it just continues on, right? This is just regular factoring. Does that look like stuff that we've been doing for like months? Okay, now check this. If I just make one little change, 9x to the 4th, and call it minus 40x squared plus 16, this looks like a different problem, right? But here's the huge part that I want to recognize. Is we haven't really dealt with this form, but notice on quadratics it goes 2 and then half of it and then none. Does this also go something half of it and then none? So if we wanted to, could we view it like this? And there's a few different ways that we can approach it. Could we call it 9x squared and think about it like this? In doing this, we can factor it the exact same way. The only thing that's going to be different about this when you're factoring is that when I find these factors, and I'm going to start off the same way, we do it identically. We'll do a 9 times 16 is 144. We still get the negative 36 and negative 4. When I go to rewrite this, instead of just writing 9x squared minus 36x, which is what we would do here, I'm going to write 9x to what power? To the 4th. Minus 36, and this is now to what power? I'm using these numbers to replace negative 40x squared, right? Can I just do the same thing here? Like, it feels different, but in reality, is this any different other than this number's a little bit bigger? It's the same type of problem. And it's hard to see that at first, but that's your huge hint. I want you guys to factor it. I know it looks worse. There's a little bit extra that we have to do, but realistically, same process with just a little step at the end. That's your tip on 16. Cool. All right. So yesterday we were talking about zeros and polynomials and all that stuff. Sketching functions. Should we do another one like that right away, or should we try to work out a really handy shortcut? Okay, so I'm going to do some stuff on Desmos for a moment, and I want you guys to help me see if we can't find a trend here. Now, not YouTube, that is always my default, and it's so strange that it happens every single time. Okay, we're going to play around with Desmos for just a moment, and we're going to see if we can't find an awesome trend and pattern. So, if we're looking at this, I'm going to write these functions in factored form, because factoring is something that we'll have to do, but give me some factors. Where do I want my roots to exist? RJ, where do you want one of my zeros? I don't care where it is, just give me a number. So if it's at positive 2, the factor must have been x minus 2. Does this one cross the axis at 2? Now, how many times did this factor show up right now already? It feels like a weird question, but it's just once, right? If I make it squared, how many times did that factor show up? twice. Okay, I'm going to keep adding some factors. X minus 6, x minus 7. There we go. Okay, as I look at this thing, can you guys tell me the roots of this function? What values of x make this factor 0, make this one 0, and make this one 0? 2, 6, and 7. Do we all agree with that? Now, I'm going to do a little bit more sketching here, and I need to move the screen up so I can see my stuff, and I'll just use that. That's fine. Okay, if I take a picture of this, and we can keep the graph, and I'm just going to put it all on Desmos, or on here. Okay, as I'm looking at this thing, super weird that I have the double line. I'm going to write out my zeros real quick. X equals, this one we said was 2, right? And how many times did it show up? Twice. And it feels silly, but I'm going to write it twice. Okay, this one is 6, and it showed up how many times? Once. And this one is 7, and it showed up once. So I just want to look at my graph here. On this root, or this factor, however you want to word it, it showed up 2 times. What does my graph do? At that 0, I know it touches 0, because that's what it means. But what does the graph of this function actually do here? Does it cross the axis, or does it just turn around? Can we all agree that it just, for lack of better language, we'll just say it touch and turn. It touches the axis, and then it turns back around. Okay, a U-turn is okay if that's what you want to use. A different class uses bounce, is what they have as their language. I don't like bounce because if it did this way, it doesn't feel like a bounce anymore to me. A U-turn is a good language. I'm fine with that. Okay, what about here? What does it do? The function, does it cross or does it touch and turn? At 6. It crosses, right? I go from positive to negative, and I can see that it crossed. What about at 7? It crossed again. Okay, so right now we have our very base. Seemingly, if it repeats, it touches and turns. Does that seem reasonable? Now, I'm going to break it real quick because maybe that's not really that reasonable. And we're going to look at one more. Let's just change the number of roots on this. And I'm just going to go back to Desmos. Okay, what if I wanted to make this one show up 3 times? And we're just going to see how it changes the graph, okay? So it's a bigger function. Now this root, or this factor and the root that it gives, x equals 2 is a root that shows up thrice now, right? It's 2, 2, and 2. What does my graph now do at the x-intercept, the root, the 0, when it shows up 3 times? It crosses all of a sudden. Do these ones still cross? Yeah, what if, well, let's just play around with it. So I know it crossed if it's 1, and it crossed if it's 3. What if I make this one show up 5 times? What do you think it's going to do at x equals 6? Cross? Does it still cross at x equals 6? What if I change it to 4? What's it going to do? Hey, it turned. Is there a pattern peeking out here? If it shows up an odd number of times, seemingly it crosses. And if the root shows up an even number of times, it touches the axis and then it turns around. Well, that seems like it's happening. Let's try it with a different function. Maybe this is just like wonky and weird. Weird. We're going to change everything. Give me a factor. I don't care what it is. Briscovia, give me x minus whatever. I don't care. X minus 4. Okay, right now, how many times does 4 show up as a root? Once. And does it cross? What if I make it show up twice? It touches and turns. What if it shows up thrice? So don't say it goes down. It crosses, right? It goes from negative to positive. My trend seems to be showing up a little bit more evidenced. What if it's 4? Does it touch and turn? What if I do 48? What's it going to do? Hey, you're right. And it gets wider. And I know it doesn't really get wider necessarily, but the graphs look different. What if it's 481? Don't say that. That doesn't make sense. It crosses. Why did we know it crossed? It's an odd number. Okay, what we are seeing right here is a huge advantage. Yesterday when we did the number line, and you guys naturally want to say it goes plus, minus, you can't use that shortcut because it depends. And it depends very specifically on our next little section that we're looking at. We are still in roots and graphs. We're still in 3.5, but we're going to define a new word that I don't think anybody in here has ever seen, but you're going to hear this word a lot in the coming years. especially if you take more math classes. So what we're going to do today is we're going to take that idea that we just saw in Desmos, and we're going to define for ourselves this new word that is called multiplicity. Okay, multiplicity. It is an ugly word, kind of. I don't know, maybe it is. What's the root word of this? Multiple. And we literally just looked at a bunch of graphs where the factors showed up multiple times, right? So there's a connection between this word and what we just saw happening. As we look at this, we're going to define multiplicity nicely. We're going to say, given a factor of a polynomial, and we'll like write out some specific things. If you give me a factor of any polynomial, which is the same thing as giving me a root, it's a zero, an intercept, it's just its slightly different form. If you give me a factor, then the number of times that factor shows up is the multiplicity. Okay. When we see this super ugly word, all that we have to think is, what multiple of times does this show up when we factor it? So most of the time on the stuff that we've seen, almost every quadratic, had two different roots that showed up one time each. Now, if we had vertex form, we get the same root showing up, which is why we bounce off of that. As we go through here, this shows up, and it is super useful. Here's our summarizing statement. If the multiplicity is, and I'm going to let you guys catch up because we're going to have two statements. If the multiplicity is, and then we're going to have two different possibilities right here. We just saw the two situations. What makes it touch and turn or bounce or U-turn, whatever language you want to use? Even. If our multiplicity is even, the graph touches the x-axis. I'm going to say touches x-axis specifically, and turns back around. And I'm just going to say turns around. Now, in the context of our number lines that we were working with yesterday, and we'll do an example of this here in just a moment, but I just want to start trying to front load it. If I was positive and I'm going to hit an x-axis or an x-intercept that had an even multiplicity, positive on this side, on the other side, what's it still going to be? If it came down and it's positive right here, coming down, it touches and it turns around, what is it still? Positive. We don't really have to calculate a value in every single interval anymore. This is a huge shortcut. If it's not even, what's the only other possibility? So if it's odd, the graph crosses. Okay. X-axis. Now, we are going to use this to help us out with constructing our sketches. Now, in the end, it winds up in these particular problems. It really only saves us probably like 30 seconds to 2 minutes, depending on how many roots we have. But we're going to use this in a lot of different places throughout the next couple of years. So we're going to make sure we get it solid right now. Okay, this idea, I'm just going to put it up here. I'm going to put some importance on this. What's more important to you, grass or stars? Okay. This is a really important idea. You can tell by all the stars. All right. Do we all have this statement down? I'm going to give you a second. I suppose. Okay. The most important thing, even, touch and turn, odd, cross. Like, we're going to use this, and we're going to start using it like immediately here. Now, for this, Lando, I'll come back to it if you need to, or I'll just give you my notes here in just a moment so you can see it's a similar statement, not the exact same. But let's use this. Sweet. All right, Lando, I'm just going to trade you. I'm going to write a problem, and I'll bring this to you, okay? So, looking at this, here's what I would like to do. Same thing. I will put it back up on that screen here in just a second, but I want to give us an example to start with. So we're going to do an example where we are going to sketch by finding zeros. And more specifically, I want us, when we're doing this, to use multiplicity. Okay. So, for our first function, here's what we're going to do. We're going to find the zeros, use multiplicity, and we're going to sketch this function. So, on A, we have the lovely function, f of x, and it is this wonderful quartic function, which means x to the fourth. So we have x to the fourth minus x cubed minus 2x minus 4. We are going to sketch this thing entirely. Now, as we're looking at this, the one thing that I do want to, we used it yesterday, I didn't formally write it. If we want to sketch this thing, do you think that it is worthwhile to do a little bit of math dance real quick? Should we figure out how it ends if we're trying to sketch it? Okay, so big decision time. Leading coefficient, what is it? 1. That's not really what I care about. Can you give me the part of it that I care about? It is 1, positive. What's the degree? 4. So that's an even number. On the count of 3, you guys, already somebody's doing it. Count of 3, we're all going to bust it, like strike a pose. We're going to do the math pose here. On the count of 3, what does this function do? With, all right, everybody's going 3. Everybody's already there. Okay, it's up and up, right? Even and positive. It ends like this. So I might, and not might, when I graph these, I will make a little note here. The first thing that I will think about is end behavior, and I know it ends like this. Up, up. With a less dumb looking arrow, preferably. Okay, so there's that part. Now is the fun part. We have to find the what of this. The zeros. So let's do that. I do that by setting this equal to 0, right? So here we go. 0 equals x to the fourth minus x cubed minus 2x minus 4. I made a comment earlier. Have we ever dealt with four-nomials? Where do four-nomials show up in all of our factoring to find solutions stuff? In grouping. Do I have a four-nomial right here? So what do you think I might try? I might try to group it. So I'm going to put parentheses here, and it's ugly, but I'm going to sneak a plus sign in between so we can do this. Remember, we want to make sure we're not magically changing something from addition or subtraction to multiplication. But I now have this, and it looks a little bit different, but as long as we recognize that four nomials, maybe grouping works, we're going to use it. It's going to be easy, I hope. What is the common factor between x to the fourth and x cubed? So x squared I heard. For this, I'm going to introduce some new language. I'm not going to write it, but it's good language to have. If we have the same variable and they're both the sum power, what's the smaller power? The least power is what we actually say. So if you say 1, where's the 1 come from? I don't even know who said it. Liam, where'd the 1 come from? With you.
Thinking, if it's x to 1, it's negative value.
Okay, so I like that idea, but we'll come back to that and I'll like touch base with you. What's the least power of x written in this group? 3. Let's take out the least power. We're going to factor out an x cubed. Now, least power, that's all we're doing. If I factor out an x cubed here, what stays inside? X minus 1. Love it. Okay, if we're trying to factor with grouping, whatever I factor out of this one, better leave behind a what inside the parentheses? Minus 1. It has to match every time. What could we factor out of this one? If I factor out a negative 2, what does it leave inside? Is it x minus 2? Ooh, let's see. Do I have a typo? Lando, you have my notes. Do I have a typo? Is it plus 4? Was this a plus x cubed? On my notes? So we're going to change the easy one so this works. Can you guys tell it's not going to work?
Yeah.
Clearly have a typo. Here's what we're going to change. I'm going to do it obnoxious in purple. Make it a +4. Make it a +4. So this thing's going to work. Whoa, I'm all goofed up here. I mixed something up. I don't know what I did. Lando's going to hook it up here, though. I don't know. We can fix it. What are we changing? And I'm sorry, I think we're going to have to erase something. What do I need this 4 to be for this to work with grouping? A 2, I think will do it. So, terribly sorry. I'm going to scratch that, and we're going to call it a 2. We're going to scratch this one and call it a 2. That's my bad. I don't know how on earth. I can't imagine that I did the whole problem without an issue. Weird. I don't know. We'll sort it out. Okay. And then what is left here? X minus 1. Yeah, sorry about that, guys. I have no idea what happened. Okay. So here we are. What are my two factors then, if we write it one more time? X cubed minus 2 and x minus 1. Now, for this, gonna be kind of ugly for a minute, but we'll deal with it, and that's not a huge issue. As we go through, how many factors did we just find? 2. Now, this is the hardest part. We can either talk about the multiplicity here, or we can do it with the zeros. Doesn't really matter to me. If we do it here, I think it's a little bit easier in my head. How many times did this factor show up? Once. So I'm just going to say that its multiplicity is even or odd if it shows up one time. Multiplicity of this one is odd, which means what is my graph going to do? It's going to cross. Now, on this other one, what was the multiplicity of this root? Why 2? So how many times does this factor show up? Where? So remember, these are the same line, right? This is the truly factored form. So if we look at this form, how many times did this show up? Just once. Can we all agree that it's 1? And 1 is a what sort of number? So what do I know the graph is going to do here? It's going to cross the x-axis. So we have odd. And I'm going to make the comment here, we're going to cross. Okay, now we could have done the multiplicity after we get the roots here in just a second, but it works just as well here. Okay, so let's keep kicking. As we get these, we have our factors and we looked at it, we did the multiplicity there. What are my roots, my zeros, my solutions, or intercepts? If we do the scratch work, this factor set equal to 0, how would we do that? If we're setting these factors now equal to 0 to get my actual x-intercepts, I'll do some scratch work here, but I'm going to erase it. If I want x cubed minus 2 to be 0, help me solve it. Add 2. Okay, so x cubed equals 2. And how do you undo a cube? So x is the cubed root of 2. And somebody with I have a calculator. I'll just knock it out real quick. Do you guys know how to type this into your calculator? Is it what? It is not with a cube, which is a weird thing. We're going to say it's approximately 1.26. Okay, so we just found a root, our first root, and it's ugly. But we'll say x equals, and we'll call it equals for now, 1.26. How about here? 1. Now, there's a weird thing that might have happened here, and we'll deal with it. We'll see other examples. But what do I do now if we're doing it the same way that we did yesterday? Number line. Okay, I'm going to put them on a number line. So I'm going to work up this direction. Only 2 of these numbers go on this number line. Only 2. What are those 2 numbers? 1.26 and 1. And the only thing that I really care about, and not this isn't true, but one of the things that I really care about, and you should, is are they in the right order? So which one's further left, 1 or 1.26? 1. And that means this number is what? 1.26. Now, I'm going to make the same comments here that we did here, and it's up to you if you want to write it. But we all see, and I hope we see, that this showed up one time. If you didn't see it yet, how many times did this show up? It's once. It's the same number, right? It better be they came from that factor. I know that my graph or my function crosses at each of these. Now, I don't know where it starts or where I'm going to start, but you guys are going to help me and we're going to pick the easiest possible starting spot. How many intervals did my groups just cut my real numbers into? How many? 3 regions. Very far left, middle, and right. Which is the easiest possible number to plug into this function? A 0. Which interval is 0 in? Left, middle, or right? The left. Now, if we plug in a 0, I don't really care where we plug it in. 0 is particularly nice to do from standard form because everything else falls out to bad next. Could we plug it in here also? Because remember, just like we saw yesterday, this, they're all identical. They're equivalent statements, which means we get a pick. I'm going to only I'm only going to find one value for this. I think we should pick 0 because that's the easiest. Are we plugging in here or here? A or B? B, sure. If I do a 0 into this, I get 0 cubed minus 2. Gives me a what number? Negative. If I plug in a 0 here, 0 minus 1 is negative. If I do a negative times a negative, what am I going to get? So check it out. I'm positive. Now, alternatively, just so you can see it, if you don't want to use the factored form, if we plug in a 0, what's 0 minus 0 minus 0 plus 2? What sort of number is that? Hey, it's still positive. Okay. Yesterday, if I gave you this problem, you would have to pick a number between 1 and 1.26. And there's a lot of them, but they're kind of ugly, right? Let's not pick one. As long as I know this is positive, if it crossed the x-axis, which it does because it has a multiplicity of an odd number, what is it now if it crossed? And if it's negative and then it crosses again, what must it be? Holy cow, these problems that weren't super fast just got way faster, especially if we have a bunch of intervals to use. From this, here's my challenge. I want you guys to sketch this graph. I'll give you a moment. I want you to sketch it for me. I'm going to pause mine. I'm going to give you a head start. I'm going to sketch it myself just based on the information that we have, and then we'll check it on Desmos to see if our graphs are close. Sketch f of x from this. Looking at this, let's do one more. Let's do a more fun function to graph. Okay, last example, I think. Then I'm going to give you guys a little bit of time to work. Yo. Yes, that's totally reasonable. Thank you, King. Okay. For the following, let's check it out. We're in 3.5 still. Ooh, love this. Okay, new type of example. Do we need another graph? Do you want to do another graph? Not really want to necessarily. Okay. We will certainly see more graphs. We're going to do a different example. We are going to solve. And I'm going to we have 2 examples that we're going to knock out. On our first one, this is going to look ugly for a moment, but check it out. We're going to solve, and on A, I'm going to just define it here, the system. Which means we have how many equations at least? 2. Okay. So here we go. I'm going to give us a lovely system of equations. My first is y equals x cubed minus 7x plus 6. It's a cubic function. Gross. Or not. We'll see. Y equals x cubed minus 7x plus 6. The second one is y equals x cubed plus 5x squared minus 2x minus 24. Okay. Been a while. We've seen systems show up a few times this year. What are the methods that I have to solving a system equation? We could eliminate. We could substitute, or we could do it the bad way and graph it and try to guess, but we're not going to do it that way. What do you think, elimination or substitution? If they're both already solved for y, let's just use substitution. And what am I going to substitute in where? Yeah, I'm just going to put y equals y, right? And then we'll just plug stuff in. So, what I want you guys to do, this problem seems awful. Maybe, I don't know, do you guys think this problem seems awful? I shouldn't open with that because how I present it probably is how you're going to view it. This problem's super nice and chill and easy and everybody's going to have fun. Here we go. I want you guys to solve this. X cubed minus 7x plus 6. we know for a fact is going to be equal to what? Love it. Okay. It is so much easier than it looks, or than it might look. I'm going to give you guys a minute. Chat it out. I want to hear your discussions. If you are struggling to start a discussion, or even to know what to do, or to try it, let me know. Sweet. I'm going to give you guys a moment. All of a sudden, by seeing this, and it's kind of gross, initially at least, this feels like a problem from before that hopefully at this point is kind of easy. If it's not, we still need to keep working at it, and we will keep working at it. But I need to solve this. What the F? Factor, right, good point. Yeah. Okay, how do we start factoring? Beef. What do you mean leading coefficient? What did you mean to say? The 5. What's so great about it? Cool. Let's factor out the GCF first. If I take a 5 out of everything, what does it leave behind? X squared plus 1 x, and I'm just going to write plus x. I don't know why I wrote 1. Minus 6. Okay, this part always kind of gets people goofed up. This 5. Anybody feel like it confuses you? Okay, if you don't want it, what could you do to both sides right now? Could we divide both sides by 5 and just get rid of it? We could. I don't really care if you do. I'm more concerned about this. This is a trinomial. How do we factor trinomials? What's the first thing we check? Now we'll check the leading coefficient. What did you say, Kennedy? Okay. What's the leading coefficient inside these parentheses? So that's nice. Why do I care that it's a 1? I'm hoping for shortcut, right? Can you give me factors of negative 6 that add up to 1? 3 and 2 add up to 5. But if I do a 3 and a negative 2, and I believe you, just so you know, but I'm always going to call you out if it's not exactly what we need. Well, how do I factor it now that we found those and that is a 1 in front of it? X plus 3 and x minus 2. Okay, here we are. It's wonderful. Now what? So kind of. Like, I think we've already solved for x, and like we could be more specific or just use different language. I claim that these three things multiplied together are 0, right? We're going to use the zero product property, ZPP. Is there ever a value that makes 5 equal to 0? Or is 5 just always 5? So if there were an x to multiply, I agree with you. But is there an x in here? So no matter what is this always equal to? It's never going to be 0. Okay, bummer. Can this one be 0? At which x value? Negative 3. Can this one be 0? When? At 2. Now, if we're solving a system, are we done? We've solved the equation, right? Plug it back in. What do you mean? What do we need? I need the y values. Now, remember, when we did this earlier this year, the order, it has to match. So, would you guys rather plug into the orange function or the green function? Good choice. Help me out here. What's negative 3 cubed? Negative 27 minus a negative 21 becomes a plus. So negative 27 plus 21 is 6. Plus 6 is 12. If I do the 2, what's 2 cubed? Minus 14? Are you sure? Negative 6. Negative 6 plus 6. 0. I think these are my ordered pairs. Negative 3, 12, and 2, 0. Now, in a problem like this, you think it might be worthwhile to actually check it on a graph? Probably. Let's check. I hope we didn't make any mistakes. I'm going to need somebody to read me that. X cubed minus, I already lost it. Y equals x cubed minus 7x plus 6. So there's that graph. It's cubic and it does that wonky thing. And then we get the graph of y equals x cubed plus 5x squared minus 2x minus 24. Okay. What did we just claim these two things intersected at? Ooh, did we make we made a mistake somewhere. Did one of them come out here at 2, 0? And the other one, we're going to go back and double check. We got negative 312, right? Where are we wrong? And here's the value in checking, right? Like, I didn't feel a mistake, but we must have made one. Where's our mistake with this? It's here. Negative 27 plus 21 is what? So I'm going back in, I'm plugging in negative 3. It's negative 6 plus 6 gives me, that should have been a 0, not a 12. Yes, sir.
You know how you put it equal to 0? It doesn't matter what side we make 0.
Correct.
Still come out as the same answer.
100%. And there's some weird stuff that happens as a result of that. And I'll talk with you specifically because it's not relevant right now to everybody. And I guess maybe it is. There's a parabola, and we don't need to sketch this, but that parabola is positive or negative? Positive. Now, if I said equal to 0, I would find these numbers, right? But maybe I rearranged it differently, and I moved so it was negative, but I still said equal to 0. The parabola now just looks like this, and it has the exact same intercepts. Like, we still get the same answers. It's just wonky when we look at the graph. Cool. All right. Doable. Okay, I guess we'll find out, huh? All right. One more problem. Last little piece. And let's do a super ugly one. Not what I was expecting, but okay. Last one. Example A, we said solve, and it was this system. On B, we're going to switch this problem up one last time. And this, just so you guys know, is going to look like 19 through 21 on your homework. We're going to solve the inequality. Now, much nicer of a problem, and it depends on really how ugly of a function we want to make it. As we're looking at our first one, we're going to do one that's a good review of everything. And here we go. I want us to determine when is it the case that 2x cubed plus 12x squared plus 12x is less than 0. Okay. Now, I just want to make sure that we can see, does this feel like the same stuff that we've been doing the whole section? I hope it does, but if it doesn't, that's all right. If I could find the roots where it possibly changes and identify where it's positive and where it's negative, would I answer this question? Like, it's just saying, when is it less than 0? And we'll go back because we use something similar. What does this mean? Less than 0. It means positive or negative? This means negative. Okay, so I'm going to lay out the approach that we're going to take here. And then I'm going to give you guys like 5 minutes. Here's the deal. I want you guys to go to the watch party after school. Watch party for the games. If you didn't catch it on the announcements, 3:15. We're going to put it on the projector in there. I want you to go to the watch party. Then I want you to hopefully go to the elementary concert tonight if you have littles that are involved in it. I'm not going to give you homework. I'm going to give you one problem that I want you to work through right now. Cool. Okay, this means negative. Here's kind of our approach. Could we find the roots? And not really could we. You can, and you will. Step 1, find roots. And then it's just like a graphing problem, but we don't even have to graph it. Put on number line. And then we're looking, once we have our number line, we're looking for the intervals that are positive or negative. Yeah, let's find negative intervals. Okay. Tomorrow, in class, we're going to have a bunch of time to work. As long as you're working, we'll have a bunch of time to work through stuff. If we don't come ready to work tomorrow, that's okay. I've got a quiz we can do. Sweet. 5 minutes right now. I want you to work through this problem. Cool. Do it to it.